Welcome to Next Gen Manufacturing. Today, we're diving into a material that is a true marvel of modern engineering, something that has totally transformed entire industries. But here's the thing. This wonder material has a dark side, a huge challenge that we're only just now figuring out how to solve. So let me just start with a question for you. Picture a material that's got all the strength of steel, but it's 5 times lighter. I mean, it sounds like something straight out of a sci-fi movie, right? But it is absolutely real. It's carbon fiber. And, well, there's a pretty big catch. Because it turns out that this incredible high-tech material is also a permanent resident of our landfills. Once we're done with it, it just stays there forever. So how can something so brilliant be such a massive problem? That's the paradox we're going to unpack. All right, so Section 1, the wonder material. Before we get into the problem, let's just take a minute to appreciate what makes carbon fibers so revolutionary. I mean, why did we all fall in love with this stuff in the first place? Okay, so what is it exactly? At its heart, carbon fiber is a composite. The simplest way to think about it is like this. You have these tiny, microscopic threads of carbon, thinner than a human hair, and you weave them together into a kind of cloth. Then you lock that cloth into a super tough polymer resin, and that combination, that's where the magic happens. That's what gives it that legendary strength-to-weight ratio. And the properties are just, well, they're off the charts. It's not just about being light and strong. This stuff doesn't rust or corrode. It won't catch fire. It's non-toxic. For engineers trying to build high-performance machines, it basically ticks every single box. It's the dream material. And that's exactly why you see it in all the coolest places. You've got it in aerospace, making planes lighter so they burn way less fuel. It's all over pro sports, think Formula One cars. It's in high-end bikes, skis, tennis rackets, you name it. It's even in medicine, because X-rays can pass right through it. Okay, but for all those amazing benefits, there's this huge downside that, honestly, we've kind of ignored for a long time. This is the unseen cost of a high-tech material. You know, the problem really starts right at the beginning, on the factory's floor. Carbon fiber usually comes in these big, flat sheets. So imagine you need to cut out a really specific shape for, say, a race car chassis. Well, what happens to all the leftover bits? Historically, they just went straight into the dumpster. And this quote just hits it home. This isn't like a cardboard box or an apple core. This material does not biodegrade. It doesn't break down. It just sits in a landfill forever. We're talking geological timescales here. Which, of course, brings us to the big question. Why can't we just recycle it, right? I mean, we recycle aluminum cans, plastic bottles, glass. What makes carbon fiber so special, so difficult? I'm sure you're thinking the same thing I was. This stuff is crazy expensive and super high-tech. Just melt it down and make new parts. It seems like a total no-brainer. But it turns out the very chemistry that makes it so incredibly strong is also its Achilles heel when it comes to recycling. Okay, here's the key difference. Most plastics that you and I use every day are called thermoplastics. Think of an ice cube. You can melt it into water and then refreeze it back into an ice cube. Easy. But carbon fiber composites are what we call thermosets. That polymer resin creates these permanent, cross-linked chemical bonds. It's like baking a cake. You can't unbake it. The material is chemically set forever. And this is the real tragedy of it. For years, the only recycling methods we had were basically just grinding it into dust or burning it. And yeah, you get something out of it, but you completely destroy those long, beautiful, perfectly aligned carbon fibers. The resulting material has none of that super strength, which makes it totally useless for the very jobs it was created for. But, and this is a big but, that's all starting to change. We're finally getting to the exciting part. Science is cracking the code, and a whole new generation of recycling solutions is coming online. And right now, there are 2 main paths forward that are emerging as total game changers. The first is a chemical approach called solvolysis, and the second is a thermal or heat-based approach called pyrolysis. 2 different ways to solve the same puzzle. All right, let's look at the chemical route first, solvolysis. How on earth do you use a liquid to dissolve something that's basically designed to be indestructible? Well, it's actually a really elegant process. First, they shred up the waste material, which just gives the solvent more surface area to work on. Then, they use a special chemical solvent that goes in and very carefully breaks apart those tough polymer chains, freeing the carbon fibers without damaging them. After that, they just separate the fibers out, clean them up, and boom, you have pristine, recycled carbon fibers ready for a new life. Okay, so that's the chemical way. The other major solution, pyrolysis, takes a totally different approach. No solvents here. This one's all about heat. The process here is just as clever. Again, you start by shredding the material, but then you cook it at a really high temperature. And, this is the important part, in an environment with very little oxygen. This makes the polymer just break down and vaporize, leaving behind the solid carbon fibers as a kind of char. Then, that char just needs to be processed a bit to purify the fibers. So what's the bottom line? Well, what's amazing is that both of these next-gen methods are incredibly good at recovering high-quality fiber that keeps its awesome properties. But pyrolysis, it has a secret weapon. Because all those gases that come off when the polymer breaks down, they can actually be captured and used to generate energy. So you're not just recycling the material, you're recovering energy too. It's a win-win. So what does all of this mean? All this innovation, what does it mean for the future of manufacturing? Well, it means we can finally start talking about a truly circular future. This is the real game changer. We can finally close the loop. It's no longer a one-way street from the factory to the landfill. We can take that waste and feed it right back into the manufacturing process. You can mix these recovered fibers with new ones or use them on their own and create a whole new generation of materials that are not only high performance, but sustainable too. And this quote just says it all, doesn't it? The entire mindset is shifting. The smartest people in the industry aren't just thinking about how to make a strong part anymore. They're thinking about the entire life cycle, designing products from day one with recycling in mind. That's a huge deal. And that's really what I want to leave you with, the story of carbon fiber. It's a powerful lesson. It's a reminder that with every incredible innovation, we have to ask the tough questions about what happens next. It makes you wonder, right? What other perfect materials are we developing right now that might be hiding a future problem we'll have to solve down the road?